Hello my dear students, after a series of NEET previous year questions, we are going to start a series for JEE question paper also for our physics subject. Today we are discussing the physics JEE question paper for the year 2023. Okay, let's start our first question. The first question says the kinetic energy of an electron, alpha particle and proton is this and this. Okay, we are provided with the values of kinetic energy and the value of de Broglie wavelength is lambda E, lambda alpha, lambda P. What is the correct relation between lambda? After observing this type of question, this is the formula based question, and after putting the values in formula, we can compare and we can get the answer. Now, according to the relation de Broglie relation, that is P is equal to h upon lambda, where h is Planck constant and lambda is wavelength. The relation between kinetic energy and momentum is P is equal to under root 2m k, where m means the mass and k is the kinetic energy. Now, simply putting the value of P in this relation, we get lambda is equal to h upon P, and for putting P, we get 2m k under root. Okay. Now, this is the generalized formula for wavelength. We simply write the formula for electron, proton and alpha particle. After putting the values for electron, according to question, kinetic energy is 4k. For proton, kinetic energy is k, and for alpha particle, kinetic energy is 4k. We get these values. Okay. After comparing these values, we can simply say the lambda for electron is higher than lambda for wavelength, and that is again higher than lambda for alpha particle. That is the required option number 4. Okay. This is simply formula based question. Moving to the next part, we are provided with two assertion and reason. This question is from gravitation. Assertion says Earth has an atmosphere where moon doesn't have any atmosphere. The reason is the escape velocity on moon is very small as compared to that on the Earth. We have to find out which is the correct one. So, the formula for escape velocity is under root 2 gm upon r, where g is the gravitational constant, m is the mass of the Earth and r is the radius. And the other formula is under root 2 gr. Okay. Now, on solving, we can say both the assertion and reasons are correct, and the reason is the correct explanation of A. Okay. Because the radius of the moon is less than that of Earth, and acceleration due to gravity is also less. As we compare the parameters of Earth and moon, we get the radius and the small g are also less for moon as compared to Earth. That's why the escape velocity of Earth is higher. Okay, that is around 11.2 kilometer per second. 11.2 kilometer per second, and for moon it is around 2 to 3 way this value. That's why escape velocity on Earth is higher as compared to moon. Moving to the next part, a source supplies heat to a system at the rate of 1000 watt. If the system performs work at the rate this, okay, this value is given for work done. The rate at which the internal energy of the system increases. According to the parameters of question, this is related to thermodynamics. So, we apply the first law of thermodynamics, dq is equal to du plus dw, where dq is heat, dw is internal energy, and du is internal energy and dw is work done. This relation can be written also in this format. According to question, the heat is 1000 and the work done is 200. We simply calculate the value of du upon dt, change is internal energy, that comes out to be 800 watt. That is our option number 3. This is question from thermodynamics. Moving to the next part, question says a small ball of mass capital M and density rho is dropped in a viscous liquid of density rho naught. Okay, we are provided with a small ball having mass capital M, density rho. It is dropped in the viscous liquid having density rho naught. After some time, the ball falls with a constant velocity. What is the viscous? We have to calculate the value of viscous force. So, you can see this is the required diagram. When the ball is put in a viscous fluid, its weight will act on downward direction and the viscous force will act in upward direction. At terminal velocity, the net force on the ball is 0. When the ball is moving with terminal velocity, it comes out to be having net force, okay, net 0 force. So, we can write the mg counterbalance F and B, okay. Mg is acting in downward direction, whereas F and B are acting in upward direction. So, we can write mg is equal to F plus B, and B can be written as, you can see mg is written as mg, F is written as F, and B can be written as V ball rho naught into G. Okay. Now, volume is given as mass upon density. We are just putting the value of volume as mass upon density, and solving we get the option number 3. This is the correct relation after solving the forces on the ball in viscous liquid. Now, the other concept is a small block of mass 100 gram is tied to a spring constant of 7.5 Newton and the length is 20 centimeter. The other end of the spring is fixed at the point A. If the block moves in the circular path on a small smooth horizontal surface with a constant angular velocity omega given as 5 radian per second, then the tension in the spring, we have to calculate the tension. So, the question can be understood in simply form is this: we are provided with a spring which is attached to one end and the other end is allowed to move. That we have attached a mass or object having mass small m. Now, we have a question says this arrangement moves in a circular path. This arrangement moves in a circular path. Okay, when any object moves in a circular path, we just equate it to forces of circular motion. So, we can write the forces of spring forces kx, F is equal to kx and is equal to m omega square r, because we know the restoring force is proportional to displacement and F is equal to kx, where k is nothing but the spring constant. So, we have balanced the spring force to circular force m omega square r. Okay, kx is written as kx, mass is given as around 100 gram, that is converted into meter, omega is 25, omega is actually 5 square is 25, r value is 0.2 plus x, 0.2 is 20 centimeter. In diagram you can see 20 centimeter length plus the required length is x. So, 20 is converted into meter as 0.2. Just solving for x we get 0.1 value of x. Now, we have to calculate the tension. The tension force is given by F is equal to k into x. The value of k is 7.5 and the value of x is 0.1, we get 7.75 Newton. That is our required option number first. Okay, this question is basically the example of simple harmonic motions oscillations. Now, moving to the next part, a particle is moving with a constant speed in a circular path. Okay, when the particle turns by an angle 90 degree, the ratio of instantaneous value to velocity to average value. We have to calculate the ratios of velocity. What were velocities? Instantaneous velocity to average velocity is pi upon x root 2, the value of x is. Okay, the question says we have already provided with the values of ratio. Instantaneous velocity upon average velocity is given as pi upon x root 2. We have to calculate the value of x. Now, when a particle is moving with a constant speed in a circular path, this diagram comes in your mind, yes or no? This is the circular path of particle having velocity component v. Okay, now we can write Va is equal to Vj and Vb is equal to minus Vi. We just divide the energy in component of x, I, j, k unit vectors. Time to reach from A to B. There are 2 points, A point and this is B point. Okay, for A we have written the velocity component as Vj and for B we have written the velocity in this direction, it is written as minus Vi. For A this is this kind, that's why we have written Vj, because when we resolve in component unit vector I, j and k. Okay, now time to reach from A to B. From time to reach from A to B is 2 pi r upon 4. Why we have written 2 pi r upon 4? Because complete circumference is 2 pi r and for A to B, this is actually one part out of 4th. That's why 2 pi r upon 4 into 1 upon V. Time comes out to be pi r upon 2 V. Now, displacement from A to B is given as r root 2. Time we have calculated, displacement we have calculated. Average velocity is displacement upon time. Putting the value of displacement upon time, we get average velocity as this. Okay, and the instantaneous velocity is minus Vi. Putting the value of instantaneous upon average and solving for x, we get x equal to 2. This is good question based simply on the formula and the application of formula. Now, moving to the next question, this is from current electricity. Two resistance are there, R1 and R2. The percentage error in the measurement. Okay, percentage error. This question basically from class 11th error topic. Equivalent resistance are connected in parallel. As we all know, when resistance are connected in parallel, we get 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2. R1 value is 10 and R2 is 15. Solving, we get 1 upon 6, because this is main part and this is This is main part and this is resistance part. So main part is 10 and the main part is 15. So R equivalent calculation this. For error calculation, we just simply write dR equivalent upon R equivalent square is equal to dR1 upon R1 square plus dR2 upon R2 square. This part is done for error calculation. Putting values of dR1 as 0.5 and R1 square 10 square 100, dR2 0.5 and R2 square 225. Solving for dR equivalent, we get 0.26. Now we have to calculate the values of error. So dR equivalent upon R equivalent into 100. dR equivalent is 0.26 upon R equivalent is 6. Okay, because 1 upon R equivalent is equal to 1 upon 6. That means R equivalent is equal to 6. Solving, we get error as 4.33. That is our required option number B. Okay, moving to the next part. The next part says, for a uniformly charged thin spherical shell, the electric potential radially away from the center of the shell can be graphically represented as. We are provided with a sphere having radius R. Okay, this is center O. We have to predict which graph is the perfect graph. So after observing, we get option number 4 is the correct, because when we are in R is equal to R means we are inside the sphere. When we are inside the sphere, the potential is same. Okay, and when we move outside, the potential and distance are related as inverse. That we get this type of graph that is known as rectangular hyperbola. So option number 4 is the correct answer. Moving to the next part. In long straight wire of circular cross section radius A is carrying steady current capital I. The current I is uniformly distributed across this cross section. The magnetic field is E. Okay, we have to predict the value of magnetic field based on the calculation of current. Now the question is about the solid infinite current carrying wire. For infinite current carrying wire, we have to use which law? Ampere circuital law. And for circular condition, we are using Biot-Savart law. So for case first, when R is small than R, we get this relation. For case second, we get this relation. Okay. So for R is less than R, we can say B and R are directly proportional. Okay. When we are inside, B and R are directly proportional. And for outside, we get the relation B and R are inversely proportional. So the required answer is option number 3. These are the application of Ampere circuital law. Moving to the next part, by what percentage will the transmission range of a TV tower be affected when the height of the tower is increased by 21%? This question is actually based on the topic of which communication system. Now the new range formula is given by under 2R h plus 0.21h. Why we have written this? Because there is an increment of 21%. Okay, so initial height is h and the new height will be h plus 0.21h. Solving, we get 1.11 under root 2 RH. It means the new range is increased by 10%, because the initial formula is under root 2 RH. Okay, and by solving, we get the new formula as 1.12 RH. Okay, we can simply understand if nothing is there, is 1 is there, and new height is 1.1. That means there is an increment of how many percent? 10%. That is our option number 4. Next question. The number of air molecules per centimeter cube increased from 3 into 10 to the power 19 to 12 into 10 to the power 19. The ratio of collision frequency of air molecules before and after increasing the temperature. We have to calculate the value of collision frequency. The relation for collision frequency is Z is equal to N pi D square V average. N is the number of molecules per unit volume. Now we can see Z and N are directly proportional. So we can write Z1 upon Z2 is equal to N1 upon N2. When solving, we get 0.25. That is our required option number first. Okay. Moving to the next part. The next part question says, the energy level of an hydrogen atom are given this ground distance N2, 3, 4. The transition corresponding to emission of shortest wavelength. We have to calculate the shortest wavelength. The relation says E is equal to SC upon lambda. Lambda and E are inversely relation. Lambda minimum is there when E is maximum, and E is maximum for which value? D. You can see E is maximum for which value? D value. So the correct answer is option number 3. Okay. Moving to the next part.